Okay, this question, we're going to deal with the ohm meter, the third page, starting on question 3, asking to test a defroster ground circuit with an ohm meter. We need to know what the ground circuit is, and I believe that some of the questions are later on, and about question 6 that's what's asking for a value. So unless you know how to do this part, you won't get 6 as well. This part right here is our wiring diagram that represents this. Okay, so this piece right here, this represents my battery, my keyed ignition, which is here. This part right here is my switch. You can see 1 represents this, 2, this. This piece right here is our resistor. It represents the grid on the window. And then, of course, back to ground. So the question here is test the defroster ground circuit with an ohm meter. What I have to do is first make sure this is on DC. That's ground. And if I look at my meter or my wire diagram, I can see my switch. And if it says ground circuit, that means it'd have to be the ground side after the load. The load would be here, which also represents this part right here, my grid. If 1 is power coming in, or we have a current flowing into the grid, which is here, and after it flows through the grid, this is going to be the ground side. So ground typically is the ground side after the load, all the way back to your battery. So if I hooked up my meter like so, made sure this was in the proper location, and I started to move my scale down till I got something on my screen, I can see I have this 0.2, 0.1 bouncing around. Like the previous questions, just basically telling us that ohm meter is not an accurate way to test for a drop or circuit integrity. So of course, if you've done this one already, you know that you cannot determine whether the wire condition is good with an ohm meter because the ohm meter does not effectively load the circuit. There's no load here. Power has to be turned off. So if I move to 6, where it actually asks you the question, your leads don't change. Check the voltage drop across the ground connection. Voltage drop, we know we have to have a power on our circuit, and we have to be on voltage. We have to roll over here to 20 volt scale because that's where my drop would be. Currently, I have nothing on my screen because I have no power going across it currently. If I turn my power on, turn my switch on, I'll get a drop. That's your drop. So check the voltage drop across the ground connection for the rear defroster system. Remember, we are basically here on the ground side of the grid, so that represents this part right here in the diagram. This is my load. Current's flowing from the battery through my switch, through the resistance or the load, which is my grid on the back window, and out, and this is my ground. So from 2 back to the battery. So from 2 back to the battery. That is your answer to that question.